I have a general term, x to the power n, what's my derivative going? Following the pattern we just spoke about before. X to the n minus 1. What's going out the front? N goes out the front. So that goes out the front. Then what did you say, Jess? N. Okay?
It does.
So following the pattern, we've got x to the power 3. That 3 goes down the front. What goes up there? 2. If it was x to the power 20, the 20 would go out the front, and that would be 19. So if I have x to the power 1, that's going to be so my 1 goes down the front. I'm just going to write this as 1 take 0. So that's 1. So I've just written that out so people understand that. Yep. Okay.
Jeez.
So if I have any number, was there a power to the x? There is no x. So if we differentiate that, what happened to that number on the end of the questions that you were doing? It disappeared. So it equals 0. Okay? So for any number, it equals 0. So see if you can figure out what that one is. Okay, so this is like a times in there and a times in there, isn't it? So that's 3 times. Now we differentiate just the x term. So that's going to be what? 3x to the power 2. The 3 goes down there. We take 1 away from it, that goes there. Plus 2 times, now what's the differentiation of x? We've got it over here. That equals 1. What happens to this number on the end? Disappears. So we get 3 times 3x squared.
9x squared.
9x squared.
2.
You're just zero.
Plus 2. So that's our that's our derivative. So our derivative of that function. So can you remember what the derivative actually is?
No.
It's the
It's like it's the rate of change. The instantaneous rate of change. Okay? Okay, so what's our answer going to be? 7x
To the power of
to
6.
the power of 6
Minus 5x to the power of 4. Plus 6x to the 2.
plus 6x to the 2.
Minus 7.
Beautiful. Yeah.
oh
Does that make sense?
yep.
You want me to write it down or you write? So from there to there was 2 times 3x squared.
Oh sweet.
So what would we have to do for this one? We want to find f dash of 1. What would we need to find first?
The differentiation.
The derivative. So we'd have to find f dash of x first. Yeah? Once we've found f dash of x, then we can find f dash of 1. And just sub in the value of 1. But we've got to find f dash of x first. So what's f dash of x going to equal? 9x squared, yep. Plus 2, yep. What's the last bit?
Take 1.
Minus 1. So once we've got that, now we can find f of 1, and so we sub in instantaneous rate of change at the point 1, what is that value telling you?
At 1,
Yep.
that's when x equals 1, y will
No.
Then y equals 1x.
No.
the rate of change is
What was the rate of change?
What's the rate of change, Grace?
The gradient. So we're finding the gradient of what?
Of the line.
The
instant.
line, what's the name of that line?
The chord.
No, it's the
Secant
tangent.
is the general form, but it's the tangent. So we're actually finding the gradient of the tangent at that point. So that some of the questions will ask you. So you've got your understanding there, which is excellent. So it says, so some questions will say, find. So this value here is the gradient of the tangent at that point. So if we've given this, gradient of the tangent is the rate of change, instantaneous rate of change. So it's not telling us to find the derivative at all. But that's where you have to make sure that you understand what the derivative means. The derivative is the rate of change. Rate of change is gradient. The tangent is when it comes down to that exact point. So what are we going to find? Yeah, we're going to find f dash of x. Two x.
Or plus 1.
It's 1. What happens to the number? Nothing. So it's just f dash of x equals 2x. But what do I want to find? I want to actually find the gradient at that point. So
So
what,
if you sub in a 3, like you go like x equals 3 and you go x equals
my x, this is my x value, remember? That's my x value. So that's the value I want, don't I? The y's got nothing to do with it. So I sub in f of 3. So what can I now say? I can't leave it. Whoops! I can't leave it like that. We've got a worded question,
Worded answer.
worded answer.
So
the
the
gradient
gradient
of
of the tangent at the point.
So that that y value has nothing to do with what we need to work out. Okay? So we're only concentrating on that 3. Okay? That 4, we don't need to do anything about it. What happens if it's written as y and not f of x?
Make it f of x.
We could make it f of x, but they've decided to be a little bit mathematical, and this comes from Greeks. Does anyone know what the sign Greek delta means in mathematics?
Oh, it's
Change.
yeah, check.
You use it in physics a lot. The little triangle,
Yeah.
the change, okay, changing. So it comes from that.
So we make
So it actually comes from the delta and the change. And when we're making that h really small, okay, in our first principles, we're making the h really small. So we're getting a small change. So it actually comes from the delta, and we call it dy dx. So that d comes from this delta, okay? So we call it dy dx this time.
what is
So instead of calling it f dash of x, it's called
what is
dy dx, okay? Dy dx. And then we just do it as normal. So that will be, what will be the differentiation of that?
6x.
Yep, just 6x. So if we've got it as y, then we use the term dy dx.
What happened again? Oh, we're shifting.
Oh.
2 times.
Yeah.
Yeah.
Okay. So if f of x is f dash of x, if it's written as y, it's called the y dx.
So is D like
Okay.
does D like short for Belfast?
Yeah, it comes from the original derivations where they use deltas instead of d's because that h is really small.
So like the D.
Yeah, but in the maths, in physics they tend to use it as that.
Yeah.
In maths they tend to use it as the d. Yeah. And you use it as okay. You use it as
Yeah, man.
physics tends to use it as a delta sign, maths tends to use it as a d. Yeah, so line x is a mathematical way of writing it. Okay, so this is the mathematical way of writing it. So now you should be able to have a crack at some questions in 17b as well. Okay?